Hello, all you cool cats and kittens. Today we'll be looking at the Chapter 8 Test Review Part 2. Part 2. So we're on question 5 now, and it says that we have a rectangular room with dimensions of 2x plus 4 and 9x minus 5. So if we want to find the area of that room, we got to do the length times the width, or the base times the height, however your teacher taught you to do it. Length times width. So one of those dimensions will be the length, the other will be the width, and we're going to just plug it in. The area equals, it's going to say 2x plus 4 multiplied by 9x minus 5. 9x minus 5. So when you do that, you got to multiply two binomials, so you're going to be doing some serious distributing here. So you'll distribute the 2x, and that will be 2 times 9 is 18, and x times x is x squared. And then you got 2 times the negative 5, so negative 10, and there was an x there. Then you're going to distribute that 4 as well. So 4 times 9 makes 36x, and 4 times negative 5 makes negative 20. And if you have like terms, you should combine them. All right, so what do I end up with? I end up with 18x squared, negative 10x's and 36x's. When you put them all together, you get positive 26x minus 20. So the area, we'll call it a of x. There's my quadratic function. It's going to be 18x squared plus 26x minus 20. And that's all they wanted for part A. So the area of our room is 18x squared plus 26x minus 20. And then they says evaluate your area if x equals 7. So take that 7 and plug it in. Take that 7 and plug it in. Take that 7 and plug it in. So the area when the x is 7, the length is 7, it's going to be 18 times 7 squared plus 26 times 7. So order of operations, make sure you do your exponents, okay? Old PEMDAS, please excuse my dumb Aunt Sally. If she was dear, you wouldn't have to excuse her, but she's dumb. So there's nothing to do in the parentheses, so we move on to the exponents, and that's what we're doing now. 7 squared is 49. So I did my exponents, 18 times 49 plus 26 times 7 minus 20. Now I can move on to the multiplication and division. I see some multiplying. Those numbers are so big that they hurt my head, so I'm going to my calculator. 18 times 49 is 882 gross. And 26 times 7, calculator. What did we do before calculators? I bet kids cried a lot more. And so now I'm doing the addition and subtraction here. And I'm just doing 882 plus 182 minus 20. My calculator's doing all the work because the numbers are kind of big. And I get, when I evaluate all of this stuff, 1,044. And it was in feet. And so since this is area, it would be square feet. Feet squared. All right. So number 5 wasn't that bad. Wasn't that bad at all. Now number 6 and 7, here we go. Number 6, state what interval the function is increasing and decreasing. So remember, think of this as a roller coaster that only goes from left to right. Always go from left to right. So let's take a ride on this magic roller coaster. Now let's zoom in. Whoa! So on this roller coaster, I'm riding the roller coaster, and it is going down. So we're decreasing. The roller coaster was going down for all of those values. And then I get down to this vertex, And after the vertex, this roller coaster roller coaster. Sorry. After that, the roller coaster is going up, so my function is increasing. So on the red part, my roller coaster was going down, down, do-do-do-do-do-do. And then in the purple part, my roller coaster was going up, so my function was increasing. So when they ask where the function is increasing and decreasing, I showed it, but now I got to answer it by talking about the x values. So the vertex is right there in the middle, and that was at x equals 0. My vertex is at x equals 0. So when x is less than 0, my function was decreasing. When x was on the right side there, when x was greater than 0, my function was increasing. So to answer the question up top, where is your function increasing? It's increasing when x is greater than 0. Where's your function decreasing? My function was decreasing on the left side where x was less than 0. It's not always like that. Look at the next problem. I like that roller coaster analogy. That's good. Roller coaster. So on the next one, where are we increasing? So remember, we're going to ride the magic roller coaster from left to right. Riding the magic roller coaster, going from left to right. My function is going up. It's increasing all night. That's terrible. So my roller coaster was going up, so therefore my function was, bless you, function was increasing till it gets to the tippy top. And then my roller coaster is going down, it's going down, it's going down. So my function is decreasing. So remember, this roller coaster only goes from left to right. If you do it the other way around, you'll be wrong. So let's see where our vertex was, or our axis of symmetry is at x equals -1. So on the left of -1, our function is increasing. So when x is less than -1, your function is increasing. On the right side of that axis of symmetry, on the right side of that vertex, aka where x is bigger than -1, the function was decreasing. So when I answered this question, where's the function increasing? X is less than -1. Where's the function decreasing? Where x is greater than -1. The roller coaster. The most fun roller coaster you've been on since last February. February. Can't remember the last time I rode a roller coaster. It's been so long. Okay, question 7 says, use the graph of the quadratic in number 6a to answer the following. Whoa, let's go back to 6a. Hey. So use that graph to talk about the average rate of change between -1, 1 and -2, 4. So I'm going to put some dots. -1, 1. It's right here. And -2, 4. -2, +4 is right here. So let's talk about that average rate of change. So I'm going to draw a little line through it. Let me use a different color because everything is starting to look the same. There it is. That's very bright. And then we're comparing that to the average rate of change between -1, 1 and 0, 0. So I'll connect those 2 points. I shouldn't have used red. I should have used any color other than red. Let's go green. Let's go orange. The orange looks just like the red. So compare them, and which slope is less, which one is less steep. Well, I hope you can see it's the orange one. The orange one is flatter. It's less steep compared to the green one. So the orange one, which was this one. This was the green one. This is the orange one. Green, orange, green, orange. So when we look at the graph, the orange is less steep, and the green was more steep. So which slope is less? Well, the orange one. That's all you had to do for that. You just had to look at the average rate of change between those 2 points. Just connect the dots and see which segment is less steep. I'm going to write that here. Connect the dots. Connect the dots. which is less steep. All right, so that is the end of that page.